Okay, so I've had this idea for a while now. An application that is a local first, free to use Miro alternative. Before we get into some of the coding, let me explain some of my motivation, goals, and plans for this app. Now why? Lately I've been using Miro and I found it super helpful for brainstorming ideas, planning tasks, breaking things down, and generally just organizing anything on my mind. It's not that I have beef with Miro, it's actually a really great product, but the features are just locked behind paywalls like the amount of boards you can have and other features. Just looking at the pricing page, you can see that. So I thought, why not attempt to build my own? That's where Rymo comes in. Ever since I built my NAS and played around with local things, I've fallen in love with using local, self-hosted products. Added with the fact that I use Obsidian, this gave me the inspiration to start this project. Okay, so let's get into the tech stack. I did a lot of debating on whether I wanted a web app or a native app. I have a lot of experience with creating web apps, but I feel like native apps are more cohesive to use and it's a better experience. Using Electron, we can kind of create this experience of a desktop application while I'm still able to utilize my knowledge and experience in TypeScript. Now let me give some brief context to what Electron actually is. Basically, Electron apps have two different parts, a backend and a front end. The backend runs in Node.js and handles file system access, window management, and system level tasks. Think of this as a server side of your desktop app. The front end is basically just a web page running in Chromium. It handles the UI, user interactions, and rendering. I did debate on using Tori instead of Electron. The only difference between Tori and Electron is that Tori uses a backend in Rust, and I don't know a lot of Rust, so I didn't want to learn a language while also building this MVP. Okay, so what's the tech stack? Again, we're going to be using Electron. It gives us file system access for our goal of local first storage, window management, and the ability to ship a single cross-platform desktop app. Applications like Obsidian, Discord, Figma, and other popular companies use this for their desktop applications. For validation and schema, we're going to be using Zod. Zod allows us to validate our JSON files, which I'll touch on more later, when reading from the disk so corrupted data doesn't just crash the app. For the front end, we're just going to be using React. It's easy to use and has lots of support, and we don't need anything fancy. For state management, we're going to be using ZooStand, which is a lightweight, predictable global state. It's a simple way to keep app state and coordinate with file saves without a lot of setup. For styling, we're going to use Tailwind CSS. For the actual rendering and canvas, we're going to be using React Canva. React Canva lets us draw shapes and interact with elements on a canvas using React components instead of canvas code. It already has everything we need built in, like dragging shapes around, detecting clips, layering elements, and transforming objects. And if we do run into performance issues later, we can always refactor this code. So let's talk about how we're actually going to store this data. There are several factors I take into account when deciding this. The first being local first, meaning your data should be easy to access and you own the data. The second is user ownership and portability. The data should be human readable and easy to move and backup, meaning no vendor lock-in. The third is simple backups and versioning. Going back to Obsidian, which if you don't know is a markdown text editor with lots of great features, you basically own your own files and everything is stored locally. Nothing is locked or kept away from you. This is the part I love. But how do we do this with rymo? The easiest way I figured is storing our data in JSON files, parsing it, and encoding it on the fly. This gives us a simple authoritative source per board that can be read or edited outside of the app if needed, meaning no vendor lock-in and you own the files. Okay, so let me give a brief introduction to JSON if you don't know what it is. On a high level, JSON is a way to structure your data in a format that's easy to read and write. Think of it like writing down everything about your fridge on a piece of paper. The brand, the color, the temperature setting, and all the items inside with their details. JSON organizes information using simple labels and values. So instead of just saying milk, you can say the milk has a fridge, quantity 1, expires January 15th. Because it's just plain text, you can open it in any text editor, share it easily, and programs can understand it without needing special tools. Here's a simple example of what a JSON file might look like for the fridge. As you can see, we have a fridge object. Inside the fridge object, we have 4 keys: brand, color, temperature, and items. For each key, we have some sort of value. As you can see, these values are of different data types. The first 2 being a string, the third being an integer, and the fourth being an array. Inside of this array, we have more objects with more key value pairs. Okay, so how will this parser actually work? To load and save these files cleanly and safely, we need to develop something that acts as a translation layer between our raw JSON data and the in-memory board model. This parser will basically have 2 jobs. The first is to decode, going from JSON to a board object. This step takes the raw JSON data and turns it into a fully validated safe board object that rymo can use. The flow will look like this. First, we read the contents of the file, then convert the text into a JavaScript object by using json.parse. We then use Zod to perform some validation checks. These checks include ensuring the structure matches the expected board format, all required fields exist, all values have correct types, and we can even provide a default value that will be applied where fields are missing. If the data is valid, we can return a sanitized board object. On the other hand, if the data is invalid, we'll return a readable error instead of crashing. This guarantees the render and canvas logic never receives broken or malformed data, even if someone edited the file manually or the board came from an old version. Second is to encode, going from board object to JSON. This happens when we save a board, and the process will look like this. The render retrieves the current board state from ZooStand. The main process calls the encode method. This basically does a JSON stringify to produce clean, human readable JSON, and that JSON text is written to the file. Because the board in ZooStand already matches the schema, encoding is always safe. Just as a side note, I'm recording this voiceover and planning before I start coding, so many of these things can change in the future. Okay, so I've never done this format before in showing kind of code and stuff that I do. So I'm not too sure how this is going to go, but I think I'm going to show kind of progress or updates as I go in code. If I have something to show or something that I find interesting, I think that I'll show that. I think it's better than just coding and putting hours or minutes of me just typing. I don't think that's very interesting. So yeah, I'm just going to put my updates, whether it's been days or hours or whatever. I think that's what I'm going to do going forward. So yeah, so what do we have here? Basically, we are in Electron project right now, and we just run it by doing npm run dev. Yeah, so I think I talked about the board decoder and encoder. So that happens right here. And basically, we just define some functions here, and our decode, if you remember, is going from the JSON to our board object. So we're just running a parse here, and we're just making sure that this parsed object matches our board schema. If not, we use the safe parse from Zod to pass the error of why it is not safe. If we just go into our board schema here, as you can see, we have outlined our board schema. I have defined this in, let me open yeah, so this is kind of what I'm aiming for our schema, or JSON kind of database, or whatever you want to call it. I think for now, we're just gonna use this. See how far that takes us. And so for now, if you noticed, we just defined our schema exactly how we want our data to show. So this board schema is kind of this whole object right here. And then we're saying this metadata object is going to be right here. We're just going to define our values in here. But for now, we only have ID, name of the board, created and updated at. This is how far I've gotten so far, just to test if this works. And if we go back to that, we're just going to run a stringify object here on the passed in board. Basically, that gives us this kind of window right here. I've taken a lot of inspiration from Obsidian here. As you can see, the left side is kind of your board, or kind of your files, which is pretty cool. And then you have your main kind of window on the right. I really like the layout of this, and I think it's pretty good. So I'm going to be taking a lot of inspiration from Obsidian. So as you can see here, we have different boards for now, just 3 boards that you can create, and you can create more. You can change the actual workspace, and then you can load your data. As you can see, we're actually parsing these values. So if we go into our app TSX, we can see that we are accessing our board object here. And how that actually works is we are passing in our useState function here into our file explorer. We go into here, and then we have some code here in the file explorer that basically, when you click a board, which is this object here, we just call this handle board click function. And then we just basically unselect board, which we're calling from above. You remember back on the app.tsx right here. And that just selects the board. And we're able to access the data from here because we have it as a board object. Okay, so just a little more kind of review here. So we go to change workspace here. As you can see, also took inspiration from Obsidian with the .rymo. Obsidian has like a .obsidian, which keeps a lot of configuration files like themes and other stuff. So in the future, I just decided to do this as well for future implementation. But for now, we're not really using that. That basically happens when you create a new workspace. So if you create a new workspace, then this folder gets created so that in the future we can have like default configurations here. All your boards here, as you can see, are stored in a boards folder just to make it a little more organized. And then inside here, you're gonna have a folder based on the name of your board, which, as you can see, matches. So we go back to my desktop, you can see that we have rymo root, which we actually have loaded right now. And then same stuff we had here. I do have another workspace here called rymo root 2, which we can go into. And then it has the same structure. The only difference is the boards, which we can actually load and see. So we can select rymo root 2, and you can see we have a big bare note, or board, sorry. Then if we switch back to the root, we have the 3 download here. So that's the basic functionality that I have now. The next steps are to create a canvas, and then hopefully we can do a text or something like that, so that we can start adding into this nodes object. So when we create a text, we're gonna add the text to the node, and then add it as a type like this. You see in the nodes, we have sticky, shape, and text as an example. So we're gonna create this one next. And the way we're gonna know it's a text is from the type. IDs are randomly generated, the position of it on the canvas, size, and other stuff like that. So yeah, we'll create the text on the canvas so that we can really test our decode and encode functions and see if they save, and hopefully it works. So we'll be back when that's done. Alright, so I have another update here, and basically we have now added the canvas and kind of two toolbars, which is the text that we wanted to add, so we can actually test the encoding and decoding functionality. Just a brief demo here. As you can see, you can pan and zoom and move these texts around, and you're able to create new text. So if we go here, you can see we have this text here and we can move it around. We've also implemented the save stating of the viewport. So if you can see, we're zoomed in all the way, maybe centered on this meow text here. We switch to a different board, then go back. You can see our state saves. Maybe we want to zoom all the way here, go back to here, and our viewport is still saved. You can see that in here, where if we look at our LOL kind of board here, and if we move around our viewport, you can see after we unselect or lift our mouse, the values over here change. So if we zoom out, values will change again. So this just saves our viewport so that we stay in the same place, basically. You can also see the same way it works with the text. So if we move this meow one, we let go, so you can see the XY values change. Same if we edit this text. See the text edits. We still have the same functionality of changing the workspace. So if we go back to here, go back to our root 2, we can open this one. As you can see, some stuff's already here. And we can go back to our other one. You can see that our viewport is still saved. You're also probably able to edit this externally. So if we just go to test in here, we can zoom in all the way here. Now let's move our viewport to 2000. Should be out of the way. Probably have to reload this. Yeah, as you can see, now we're further away from this. Okay, so let me quickly run through some of the code that I added and how I actually did things. So I've decided to make a registry for the toolbar and tools so that in the future it's easy to register new tools and have them appear on the toolbar or whatever you want to do with them. So basically we can just call this register method here and I can register it to our toolbar. And we can have a couple more helper functions here to help us get information about the tool. So for example, in our text tool here, as you can see, we're going to register this text tool to our registry, our toolbar registry. So we actually use this mode in our infinite canvas in this function right here. And basically, if the mode is equal to adding text, then we are going to actually add the text node. This function is quite long and we actually probably should move this to a different function, especially when we have more modes. This is going to get quite long, but that will be in the future when we have more nodes to actually add. As you can see, this is the text node class. I'm not going to go through all this code, but this is basically kind of the actual stuff. So the Canva text we're using to actually render the text on the canvas here. We're still using Zod for all of our validation and schemas to ensure that all of our data is safe. As you can see in our infinite canvas, we have a bunch of other kind of functions that help us actually manage the canvas itself, such as handling the zooming of the scroll wheel and handling our panning. Okay, yeah, so it might not look like a lot, but I'm pretty satisfied of what we got done this week. Spent a lot of time on debugging and trying to figure all this stuff out, as a lot of it is quite new with the libraries that I'm using. A lot of this is just groundwork so that in the future it'll be much easier to do all of this stuff. So it should only get easier from here. Yeah, just as a recap, we were able to get the decoding and encoding of the JSON files. We were able to implement this infinite canvas class that handles our canvas. And then we were also able to implement a registry for our toolbar and just a toolbar in general, and adding two tools, which is our select and text. And then we were able to actually implement creating new boards and saving them and changing workspaces as well, which is just part of our encode and decode methods. And so the plans for next week is to actually implement the edges, which as you can see here, we're going to implement this. Basically, the edge is going to define what is on the edge of each node. So in Miro, you can actually have an arrow on an edge of a node pointing to another node on its edge. And basically, we want to implement how that works. So we can point this node to this node, and we can define if it's an arrow and having a start and end arrow and all of this other good stuff. All right, so that's it for this week. I'm going to be posting reviews every 2 weeks, so hopefully that gives me a little more time to work on projects, stuff like that. I hope you enjoyed this episode, and hopefully it kind of showed you what I'm doing this week. And hopefully next week we can make more progress on this and have some other stuff that we're doing. Other than that, I'll see you guys in 2 weeks.